Alright, we did a real brief introduction to standard form in the last video, more as a just reminder than an actual introduction. We're going to talk about general conic form instead here, and I'm going to also start by just making a quick note about something that seems to be missing when I look at this formula. We see A, C, D, E, and F, but there's no big B here. This general form we're looking at is going to be reflective of future videos when I work with other conic sections. This is not something that's very readily apparent with circles because circles are sort of like your perfect shape. No matter how you rotate a circle, it will generically look the same as long as it's just a baseline circle. For this though, there's a term, a BXY term that would be here for other conics, for parabolas, hyperbolas, ellipses. And the idea would be that that B value really plays into how you rotate that imagery on the coordinate plane. But because we're dealing with circles especially, and because I don't want to go too deep into the rotational aspect of these things, we'll be ignoring the B term for these problems. Or rather, we'll be saying that our B value is 0, so it knocks that term out of the problem. And this tends to look pretty intimidating to a lot of people when they first see it, because it's a lot of stuff going on. But the big letters here, the A, C, D, E, and F, those are just coefficients and numbers. Really, this is no different than dealing with the standard form we had previously. Suppose you were given standard form. Let's say we had x plus 4 squared plus y plus 13 squared is equal to 25. And I told you to write this in general conic form. So here we are. We're going to write this in general conic form. One thing we did in the last video was identify the center and the radius. We won't need to here, but as a good reminder, our center in this one will be -4, -13. It's always the opposite of what's in the parentheses. And then our radius would be the square root of this number on the right, which in this case would just be 5. If they give you standard form like this, and they tell you to write it in general conic form, this is the easy direction. In fact, it's very different to go from general conic form back to standard form, and it's different enough that will probably be our next video. But for this, all we're going to do is actually take this stuff up here and square it out, get it all moved to one side of the equation, and simplify anything that we can. So for example, x plus 4, if I square that, we get an x squared term, we get 8x, and we get 16. So this is the first part, the x plus 4 squared. Then over here we would get y squared plus 26y plus 169. And that's all still equal to 25. I have to apologize for the stuffiness. I've been dealing with allergies a bit lately, and that's going to probably come through in some of these videos, but I want to keep this going. Here we're just going to have a simple matter of bringing everything together. So first of all, we need to subtract 25 from both sides. Notice up here we're set equal to 0. So I'll subtract 25 here, and that's going to drop this to 144. But then I've got the 16 that I want to combine with that. So let's move that 16 over. Now notice I'm not switching sides of my equation. I'm combining like terms. I subtracted the 25 because it jumped the equal sign, but I'm adding the 16 still because it's on the same side of the equation. So 144 plus 16, this would be 160. So what I'm going to do is do a little rearranging. They always group the highest powers first, so x squared and y squared. So I'm going to do x squared plus y squared. And then they go kind of alphabetical as well, x and y, plus 8x plus 26y plus the 160 that we just came up with. And so this right here would be our general conic form for that particular circle. Notice it looks pretty different. I'll have to admit it looks very different in a lot of ways. You can already kind of get an idea though how this down here will connect back to the original just by seeing that the 8 is twice the 4 and the 26 is twice the 13. It's a pattern you expect to see kind of showing up pretty regularly. And we'll kind of manipulate that pattern later when we work backwards. We'll use those numbers here to kind of tell us how we should shape things. What we're going to end up needing to be able to do though, notice we lose sight of the 169, the 16, and the 25. They all sort of merge into one big number, and we're going to have to figure out, using these values, how we can kind of pull that back apart, kind of tease out what those old numbers used to be. As a note, if they give you a center and a radius, we'll just do it like this. If they give you a center and radius and tell you to write this in general conic form, this is really the same setup, the same type of problem. All they're wanting you to do is take this, write your standard form first, then convert. So we're going to do that very quickly. If I take this and write it in standard form, we get x minus 9 squared, y plus 1 squared, and when I square 2, we get a 4 on the right-hand side. And that's really the only extra step. You have this one extra step, and then it's just like the last problem. So to do that, we get x squared minus 18x plus 81, so that's just squaring this first guy. The way I do this, by the way, is my shortcut for squaring a binomial, is I just go square the first, double the product, so negative 9 times x, and then double it, and then square the last. So then square the y, multiply these guys, you get 1y, but we have to double it, and then square the last, and then we just have to bring everything together. So 81 plus 1 would be 82, but we're going to subtract this 4 from that, so we get 78. Then we want our y term, we want our x term, we want our y squared, we want our x squared. And there we go. So just double checking all my values, we had x squared, we had y squared, we have our negative 18x, we have our 2y, 81 plus 1 was 82, minus the 4 was 78. And there's our general conic form.